Hello everyone, this is Balaji. I'm currently doing my master's in the domain electric and hybrid vehicles in ARI Academy. And electric and hybrid vehicles is a subject which is a part of my curriculum, and have been instructed to do a assignment on finding the electrical loads in electric vehicles. So I chose Tesla Model S. The reason behind choosing Tesla is because my dream company and my dream job, I mean, the place where I wish to work is Tesla. So that's why I chose Tesla Model S. Tesla, and in Tesla, I chose Model S. So if I tell you about the vehicle, Tesla Model S, the model which I chose is Tesla Model S P100D, which has ludicrous mode. And it is the third fastest accelerating production car ever produced in this world. We all know that electric vehicles are rapidly increasing all over the world. I mean, the production is increasing all over the world, and Tesla is the leading company which produce electric vehicle in the market. And in Model S, the ludicrous mode is nothing but the acceleration, which we can get in 2.4 seconds. I mean, we can accelerate the vehicle in 2.4 seconds with a speed of and get a speed of around 60 miles per hour. So that is why it is called as Tesla Model S P100D with ludicrous mode. It's a specific feature in Tesla Model S, and it is a good feature when you compare with other electric vehicles. And Tesla Model S ranges up to 289 miles EPA, and it is an estimated around 542 kilometer range in the normal NEDC cycle at a single charge. So let's talk about the powertrain specifications of Tesla Model S. So Tesla Model S is pure electric vehicle. It doesn't have IC or any other source of powering the vehicle. It's a pure electric vehicle, and it is a battery operated vehicle. So if you take IC engine, the engine is the power source, the main power source of the vehicle. But in Tesla, the battery is the main power source. And for getting traction in the wheels, electric vehicles use motors. So in Tesla Model S, the electric motor type is AC induction, three-phase AC induction, asynchronous motor. It has two motors. I mean, motor 1 in the front and motor 2 in the rear. The motor front gives you the power up to 375 kilowatt at 5000, nearly around 6000 rpm, which is exactly 5950 rpm. And in the rear part, there is also a motor which powers you, which gives you 195 kilowatt at 6100 rpm. And the torque in the motor 1, we we could see that the electric motor 1 gives you power around 375 kilowatt. So obviously the torque in the motor 1 is also higher when you compare with the torque in the motor 2. So in the torque in the motor 1 is around 600 newton meter, and the torque in the motor 2 is around 330 newton meter. The Tesla drivetrain is all wheel drive. It's nothing but the four wheels are used to drive the vehicle. It's not like a rear wheel drive or front wheel drive. It's all wheel drive. It's a unique feature in Tesla vehicles. And the voltage around this voltage which is supplied to the motor is around 320 voltage. So if you could see the picture which is below the table is the Tesla Model S drivetrain. So if you closely look into the picture, I, let me zoom in the picture. So if you could see the picture, this is the motor, and it is the rear part. You could see the front part also has motor. So this is the powertrain of, sorry, drivetrain of Model S. And the next thing, electric loads. Normally in any vehicles, take IC engine, hybrid electric vehicles, and also electric vehicles. Electric load is a predominant thing. Every auxiliary applications need electric loads, and not only auxiliary applications, many higher applications also need electric loads. I mean, if you take IC engine, we have alternators, which is an electrical component. So that needs an electrical load. So likewise, electrical load is an important thing in norm in normal vehicles. It can be either IC engine or hybrid electric vehicles or electric vehicles. So in Tesla Model S, the battery is the, as I told before, battery is the main power source, which is a, which is the default power supplying device in the car. So the battery is supplying power to I mean, each and corner of the vehicle. It can be motor, it can be wipers, it can be steering system, etc. So battery is the main powering source in the Tesla Model S. So let me discuss some specifications about battery. Tesla uses Panasonic battery of 18650 model, and it has 85 kilowatt hour of capacity, and in the current market, the one which Tesla using is the best battery for energy density, and the reason behind its good output is because of the miles per charge. For a single charge, it could give you around 200 miles. So that is why in the recent market, in the current market, this battery is the best. And Tesla models are arranged in 74 parallel and 6 series configuration, and the nominal voltage, if you see the Tesla nominal voltage, cell voltage level, it's around 3.8 voltage, and in the module level it's around 28.8 voltage, and the energy density of the battery is around 160 watt hour per kilogram, and the voltage cutoff, it's around the maximum voltage, it's called maximum, you can say it as maximum voltage, so it's around 4.2 voltage per cell and 25.2 voltage per module. And the same for discharging cutoff, it's the minimum voltage level, it's around 3.3 voltage. It can go around 2.9 voltage also. Basically we say, we predict it as 2.9 voltage per cell, but in Tesla Model S it's around 3.3 voltage and 19.8 per module. And the maximum discharge current for 10 second, the discharging current for 10 second is around 750 amps. So these are the things, are the general battery specifications of Tesla Model S. So let me show you the picture of Tesla battery pack. Let me zoom in the picture. So if you could see the picture, this is the underground floor mechanism. You mean the battery is under the floor of the vehicle. This is the Tesla battery pack. So if I if I talk about battery thing in Tesla, I should talk about the charger, how it is done, and in other, I mean, in different parts of the places, different types of charging thing is followed. So onboard charger. Usually electric vehicles have onboard chargers, and the Tesla, it has three types. One is Tesla charging inlet, and the current which is used for that is 72 ampere, and it is located in USA and Canada. And the type 2 has power of around 11 kilowatts, and it is located in Europe and rest of the world. And it has another Tesla charging inlet which is similar to that of first thing, but the power value and the current value is not similar. If you see the charging inlet in the first point, it's around 72 amperes, but in the third block you could see the charging is around 48 amperes, and the power is around zero point 0.5 of additional of zero point 0.5 to the type 2 charger. It's around 1.5 kilowatts, and it is located in USA and Canada. And this is the charging type all over the world. This is one type of charging, the charging methodology for Tesla Model S. It's called as NEMA 515. The voltage range is around 120 voltage. The current range is around 12 amperes, and the power is around 1.44 kilowatt. The unique feature of Tesla Model S is it has supercharger. If you could see the last part of the table, it's supercharger. It's Tesla's unique feature, unique charging type, and you could see the power is around 120 kilowatts, which is enormously higher than the other methods of charging types. See, the maximum is around 11.5 kilowatts in wall connector, which is around 250 voltage and 48 amps. But if you see the power of supercharger, it is around 120 kilowatts. Normally, the voltage range of supercharger is around 240 to 480 voltage. So this thing is a unique feature in Tesla production thing. So this is the Tesla charging station. You could see this is the grid, and from the grid the charger is connected to the vehicle. You could see here, let me zoom in. You could see here the charger is connected to the vehicle. So this is how the wall connector, I mean the Tesla charging is done. So in normal IC engine vehicles, we could see alternators in place of converters. The main work of converters is to supply the voltage for auxiliary applications. If you could think a little bit, normally in any vehicle, for example, take wipers or headlights. You don't need the traction voltage capacity. It's around 300 voltage. Take it as around 300 voltage, the traction voltage. The motor, I mean the voltage which is required by the motor for traction is around 300 voltage. So you don't need the full 300 voltage for powering the headlamp or wipers or steering. You don't need 300 voltage. In such cases, you will need voltage ranges around 12 volts, something equal to 10 volts, or something related to 20 or 15. So in that case, converter plays a major role. The use of converters is to buck or boost. It's nothing but reduce the voltage. Step up the voltage or step down the voltage. And the converter is also used for charging the 12-volt batteries. The main use of 12-volt battery is for the usage of, I mean, the 12-volt battery is mainly used for powering the auxiliary applications, which is nothing but the wipers, motor, I mean the seat adjustment motors, the steering system, infotainments, and etc. So for that thing, the converters are mainly used. I mean, for if you see the sorry, if you see the third point, this converts high voltage DC from the battery pack to low voltage, that is around 13 to 14 volt DC to charge the 12-volt battery. So it's nothing but conversion of high voltage DC supply from the battery to low voltage, which is around 13 to 14 for charging the 12-volt battery. And the converters accepts. Normally, it is being said that the converter is used for converting the high voltage DC to low voltage DC. So it accepts around 20 220 to 430 voltage at 15 amps and outputs and gives the output around 9 to 16 voltage of DC current. So this is the converter which is used in the Tesla Model S. If you could see the picture closely, let me zoom in the picture. This is the converter which is used in the Tesla Model S. So alternators. As I said before, no, I mean the electric vehicles doesn't have alternators. Instead of that, they have DC to DC converter, which I explained before. So the usage of DC to DC converter, it's because of its static nature. It doesn't move or it doesn't move like alternators. I mean, a small part of movement will be there in the alternator, but in DC-DC converter, it doesn't actually move, and it doesn't have any moving parts. But in the case of alternator, it has some moving parts, and it is relatively efficient when you compare with alternators. And in the regenerative braking type, the Tesla Model S gives you around 60 kilowatt of power, and this power, I mean, if you get this much of power, the energy consumption reduces. I mean, the energy which is used, I mean, the energy which we are using from the battery gets reduced and improves the brake lifetime. So in Tesla Model S, the regenerative braking system is used. I mean, may be may utilize normally the Tesla motors utilize regenerative braking for the increase in the mileage. Normally we don't say mileage in electric vehicles, it's called range. So it is mainly utilized for increasing the range of the vehicle per charge. So as I said before, the converters are used for converting high voltage to low voltage, which is to charge the 12 volt battery. It is basically of lead acid battery. So for the lead acid battery thing, there are, I mean, the lead acid battery supplies power, I mean, gives its power to many auxiliary applications like wiper motor, seat adjustment, power windows, lighting applications, infotainment, and seat adjustment thing, and there are many more things. Basically, the AC compressor, it is also an auxiliary application. The AC compressor works off at 400 voltage. So might be it can might I mean it can use the traction application for powering its compressor, and this compressor sits at the front part of the car and draws. I told you that this AC compressor may get its power from the battery. So that is why this AC compressor is mounted in the front part of the car. So it can get its power from the battery pack or the energy storage system, which is in the Tesla terms. So if you take AC compressor, it gets its power from the battery pack, the main battery pack. So lighting system, there are some lights. I mean the lights, headlights, fog lamp, license plate light, interior lighting, and the puddle light. There are such kind of lights which has its voltage range around 12 to, it increases based on the application. So if you take car door projector LED lights, it gets its output from the secondary battery, and its range is around 12 voltage, and the power, the watts is around 6. If you take xenon headlight, basically xenon withdraws more power. So if you see here, normally headlight ranges around 12 or 10 or 11 voltage, but if you see the xenon headlight thing, the voltage range is around 42 voltage. So obviously it will extract more power. I mean, it needs more power. So if you see here, if the voltage is around 42, the watts is around 35. It's this is what Tesla is using for their headlight. And the LED bumper reflector, right, it's around 12 voltage and 6 voltage. It is basically equal to the car door projector LED lights. And the combination rear light, it's also around 12 voltage and 5 to 6 watts. See, if you see the xenon fog lamp, the xenon fog lamp and the xenon headlight, it's somewhat similar. But the if you see the voltage range and the voltage range, the headlight uses 42 voltage and the xenon fog lamp uses 85 voltage. Fog lamp is a very important thing in any vehicle, and the wattage is around 35 volts. And the interior lighting and the license plate lighting is somewhat similar to 12 volts. This is the Tesla puddle light, the symbol which, if you open the door, the sorry, if you open the door, the light will reflect on the ground, which shows you the Tesla symbol. These are the lights which are used in the Tesla Model S. So these are the things. I mean, these are the loads. Basically, these are the loads which are used in the electric vehicle. I mean, from the battery and the secondary battery, the power is going to these things like lighting systems, wiper motor, seat adjustment, power windows, which uses 12 voltage. So these are the basic things of an electrical load. So I conclude my presentation, I mean the assignment, with this thing, with this lighting system. So these are the references which I searched on for getting the details on the electrical loads and other things of Tesla Model S. So I, from this assignment, I came across many things, and being my I mean, I told in the beginning that Tesla is my favorite company and my dream company. I learned many things about Tesla Model S and other things, and this assignment helped me in gaining many knowledges on electric vehicles. So with this thing, I'll end up my presentation. So thank you very much. Thanks a lot. Hope this gives you some insights about Tesla Model S and its electrical loads and other important things in Tesla Model S. Thank you so much.